Okay, guys. So first of all, I need to thank Ohad for this panel, who brought the topic to our attention. I think that the topic of how do you actually build OpenStack is actually a very interesting one and something that everyone would need to go through. So what we thought of doing, rather than talking about a particular way of doing it, have a distinguished panelist that will talk on the different ways of doing it, and a couple of approaches that each one of them represents. So we got Ohad from Redhat, who will talk about the framework that he's building and is now being used in Redhat, Foreman. We got Shevek, who I just learned have some Israeli, I wouldn't say roots, but at least background. Which is coming from Nebula and would represent kind of an appliance model. We got Omri, who was an ex-live person guy, and now is in Revizer, right? And he will represent the consumer side of things, those who actually use the stuff. And Alex, don't need any other introduction. I think you heard a lot from him today, so Alex, I think, represented himself. So I think really the way I wanted to lay it out is really throw a few questions to them, but really give you the opportunity to ask questions. That's really the important thing. So we'll start with a quick introduction, and we'll start the discussion. So we'll start with you, Ohad.
Okay, hi everyone. So Nati already gave an introduction. I'm Ohad, I work at Redhat. I'm the creator of a tool called Foreman, which his whole purpose in life is to help sysadmin, DevOps, and similar people to maintain their infrastructure.
Hi, I'm Shevek. I work at Nebula in the office of the CTO. I'm responsible for discovering new technologies and new ideas and for understanding high-end technology and how it can be applied and brought into the OpenStack world.
Hi, I'm Omri. I'm ex-live person DevOps. Now I'm a DevOps at Revizer. Basically, I was in task of introducing new technology that live person, OpenStack was one of them. And now I'm doing the same at Revizer, basically integrating new technologies there as well.
I'm Alex Freedland, represent Mirantis. We build clouds, and also we're the authors of well, we have Mirantis OpenStack, but also the control plane for that is a product called Fuel, which is open sourced on StackForge.
Good. So I think the first question to the panelists is, if I want to get started with OpenStack, where should I start? What's the best way? What's the right tool? Is there a different tool for production? Is there a different tool for development?
Yeah, I think the first question is, what are you trying to do? Are you trying to build a cloud, or just trying to play around with OpenStack and see what it's all about? And there are different tools you're probably going to use. Most likely, I mean, even though you can probably use the same tool, the complexity of deploying a development environment is a completely different set to a real production environment. And as such, you should be looking at all the alternatives. Pretty much, I'm guessing that development is DevStack or similar, and you probably need to agree at some point in time what is the distribution of OpenStack that you want to install. But if you're talking about production, I think there's a big difference the way you just deploy it in a lab versus a real usage scenario where you want your infrastructure. Even if OpenStack is built out of bare metal, you still need agility in order to build multiple clouds, multiple versions of OpenStack, allow rolling upgrades, and so on. So again, it depends on what is the scenario. If you're picking Foreman, for example, or Mirantis, we both rely on common we both rely on common frameworks such as Puppet. The complexity of OpenStack is pretty huge. Like any major distributed application, OpenStack itself is lots of moving parts. So therefore, I would advise you not to try it yourself. To start from scratch. That's probably not going to get you anywhere in the near. Unless you have really a lot of time. But we try to use as much as possible open source initiatives, things that are managed by the community, and a lot of, I think in operations in general, if we talk about production, operation is kind of an art that you earn through a lot of blood, sweat, and tears. I think you never get it right the first time. You always have to continuously learn from your mistakes and improve. And open source actually allows us a really unique opportunity to learn from other people's mistakes as well. So you should ideally choose something that has some mileage in it, and you know, ideally a large community around it, and users and people that are generally interested to help you. And I'm putting my open source hat for a second and not the commercial one, assuming most people don't want to invest money on day zero. So if you're an early adopter, go for a good open source alternative, something which is easy to install, easy to consume, and most likely you'll have some bumps over the road, but ideally there are a lot of good people around that wants to help you get it right.
Now, building an OpenStack environment includes, at the end, also the hardware component, which is the routers, the network, the storage, all those pieces that needs to come together. I know that Shevek, one way to deal with that is kind of an appliance model in which you get the software and hardware kind of integrated. Maybe you could spare a few words about that.
Yeah, I was going to ask the audience, how many of you, this is audience survey time, how many of you have a wireless network at home? Anybody with your hands down, I don't believe you. How many of you bought a box for $100 or whatever and plugged it in? How many of you built your own using host AP and a Linux box with a wireless card in? One. Okay, you're the special case. Everybody else bought a box, they plugged it in, it worked. The Nebula appliance model is very, very similar. It's a box with network ports on the back. You plug it in and you turn it on. What you then do is you buy your own compute nodes. It largely doesn't matter what they are. We do have an HCL, which helps. And you plug them into the network ports on the back of the box. And when those compute nodes boot, they will then be running OpenStack. And it really is as simple as buying a network router at home and plugging it in. Now, the question as to whether you are experimenting or running a full enterprise scale application still applies, because the Nebula controller itself is designed to be failure tolerant between controllers. So if you're just experimenting, much like you would at home, you buy one cheap wireless router, you plug it in, and if it loses power or something, then you lose your home network. If you're running in the enterprise, you buy a Cisco version Mumble AP with 15 endpoints and redundant power. And the Nebula controllers can work exactly the same way. You plug 3 or 5 of them in together, and they deal with failure tolerance between themselves, and then if one of them loses power or gets set on fire by an accidental sysadmin, the system as a whole keeps operating. Now, once you've plugged your compute nodes into the back of the controller takes them over. It will install the base operating system onto it. It'll install OpenStack. It will install the storage engines. It'll install Nova, networking, and everything else onto those systems. And you never actually need to know or care about it. One of the big advantages we get about making all of that stuff signed and sealed is that we get to execute an NSA-style security model on it, where every single component of that OpenStack distribution is signed and sealed and can be verified all the way down to the TPM on the motherboard. So you can go to a Nebula controller and say, has this distribution or has this system been broken into, yes or no? And the isolation between your VMs and the protection against things like zero-day attacks in that sort of system is absolutely extreme. In terms of storage, there's a mixture between the ability to use the internal drives of the systems that you've plugged in for distributed storage and an ability to integrate with external storage devices through Cinder. But basically the principle is to make sure that you don't have to think about it, because much as you're all using laptops where you didn't install the operating system, we at Nebula think you should not have to be installing the operating system on your cloud either. It's not your job.
So we got two, I wouldn't say extreme approach, but two different approaches. One of them is it's complex and we'll build automation around it to make the complexity simpler. And another approach in which let's put all the complexity in the box and kind of give you the appliance model. Everything is pre-integrated. Obviously, there is a pros and cons in each of those approaches. I'll point a question to you. I mean, you had this dilemma as well, going with Alex with the trunk versus going with the, I think the cloud scaling is taking similar approach to the Nebula ones, right? from a hardware plus software kind of integrated. What was your thought about the integration versus staying on trunk and building automation around that?
So the way we looked at it is we said, why do people need OpenStack? I mean, what's the use cases? And we realized that OpenStack is really a control plane for the the software-defined data center, and as that being the case, will be consumed in multiple different fashions. It will be consumed in on-premise model, in the public cloud, in the hybrid cloud, and all that. And so, in order for customers to be able to make decisions, they need to have ultimate flexibility as how they consume it. And the appliance model is one of the ways to do it. It's very opinionated, and so it's I can see in a hybrid mode that the appliance can have potentially a place in that. But ultimately, it's about OpenStack being the ultimate open system that people can configure however they want in a simple way. So we decided that we'll create a control plane. We'll take the absolute trunk version of OpenStack, and we will allow people an easy way to choose the operating system they want, to choose the hypervisor that they want, to choose the HA versus non-HA configuration, however they want to do it. And then, you press a button and OpenStack appears, right? So we figured that the reason people go into OpenStack is to enable choice. And that's kind of one part of the story. And then the second part of the story was said that the only way for OpenStack because of those of you who saw my presentation, we believe that there will be only one distro of OpenStack, and that's OpenStack itself. And so the only way to kind of be consistent about this is to make sure that whatever decisions you make will be very much integrated with where community is going. So whatever things we're doing outside, we're doing only for the time being until the community version is catching up. And then as soon as it's catching up, we're integrating with as many things as possible. So to this effect, we see that the way to actually deploy OpenStack is triple O Tuskar combination. And Fuel is a mechanism to, first of all, expand the capabilities of it. For example, we're doing a lot of it is environment, so we're doing a lot of pre-deployment checks to make sure that the environment actually has all the network configured properly and the like, and then writes different tests. Also configuration as to what configuration of different parameters you put in. So that is about to make its way inside the big triple O program as a value add. And then as triple O became much stronger, we'll replace the provisioning things with the triple O engine and some of the other things with Heat, and then essentially OpenStack will become mature enough to kind of install itself, and Fuel will become part of that. So as it
one way
evolves,
to summarize it, let me know if that's an accurate summary of that. It's extreme simplicity versus extreme flexibility. I think that's the trade-off that you need to choose. Omri, you've done it, or you're doing it twice right now. You've done it in a certain way before by going with the trunk, and now you're doing it with Foreman, right? If I understand correctly?
Yeah, Foreman and Puppet, basically.
Okay, so in both cases Puppet, but before it was taking the trunk version of OpenStack and then using Puppet directly, and now using Foreman, right? So maybe you can describe the decision, why you've done it with trunk and directly with Puppet, and now on the second iteration you're doing it with Foreman.
Well, first of all, when I started at LivePerson, it was version of Cactus, basically, which didn't really have so much support. Packages were like so. So I got used to actually tinkering with a lot of the code, which I had to do since it was actually impossible to install it otherwise. Diablo is getting better, and in Essex we felt that was actually good enough to use in production, and still Puppet modules weren't really mature enough at that state. Now when I approach it like Havana, which since that's the version that I'm installing at Revizer, I've actually have the sense that it's much more mature and everything is much more stable, so I can just take it out of the packages that I have in Puppet Forge or whatever, and it just works out of the box almost seamlessly. With Fuel or or without. So it's a lot easier to configure today. I mean, I do have the advantage that I tinkered with it, so I know how everything works. So if something breaks, I can actually fix it a lot faster. But I don't have to so much. It actually works pretty easily.
So that's very interesting, because basically what you're saying is that as long as you didn't have enough trust in the framework, you felt that you need to have very tight control over it, and therefore adding a tool kind of abstract you from that infrastructure and therefore the control. The more the underlying infrastructure become more mature, you feel more secure about it, and then you could more easily plug in another layer on top of it, which is providing the automation. And that's kind of, so it was a question of the maturity of the infrastructure that affected the decision of the tools that you used. Have you considered an appliance model versus tools, or?
Well, since I have a lot of experience with Puppet and everything, actually I decided to just use what I'm feeling more comfortable to do, which is actually Puppet. I have thought about using other resources, but every model has its own advantages and disadvantages. I personally prefer having more control over what I have, and using an appliance is actually a bit like against what I feel more comfortable with.
I see. Okay. I'll stop here for a question from the audience. Anyone here, by the way, have built an OpenStack environment? Okay, so let's start with you, Mesh. What did you choose? So the question is about redundancy and high availability setup, right? Okay, so how do we set up a high availability for OpenStack environment? Shevek.
I'll go, since we basically predicated a lot of the company on the fact that we were going to be redundant and failure tolerant. Every Nebula controller runs every element of the OpenStack control plane, and the OpenStack control plane is broken out into all of the multiple components, and any OpenStack component is allowed to fail on any controller individually, and the request will just get routed to other controllers. So we can do database state failover, any of the API endpoints can fail over, any of the memory pieces can fail over. And in fact, a part of the background to the presentation that I gave upstairs, and I didn't want to go into specific examples, is that we're actually working on doing a lot more multi-master stuff, because we do actually speak to customers who say that failover is no good. If you're banging 100 requests a second or 1,000 requests a second at an OpenStack cloud, and it has to fail over, well, the question in any failover architecture is, was that a 10 millisecond ping delay, or was that a failure? How long do you have to wait before you detect a failure? So we're even moving from a fine-grained failover model to a multi-master model for all the components that we can possibly get that into, so requests don't get dropped at all.
So I guess, HA means different things for different people. And HA in OpenStack usually means every service by itself needs an HA of its sort. And I don't know which part you were focusing. Each component has, one of the complexity in OpenStack is really about the option that you have, right? All of that options gives you a huge amount of scenarios that you can pick from. Like even if you say HA, and ideally I would envision a UI saying checkbox HA, that means a lot of things, right? And there's lots of, it depends. Are you using this backend for storage or another? Are you using whatever, a plugin for Neutron or so on and so forth? So really, I don't have an out-of-the-book answer saying, like, because I'm not opinionated in how you're going to deploy OpenStack, it might mean different things based on the choices you've made. What we can do is we can, and this is the Redhat part, saying we can certify well-known use cases in HA, meaning we know how to do database HA, we know how to do Nova HA, we know how to do every component basically, and provide you a reference, provide you even a very nice UI that you can choose what is the scenario that you want to apply, and we'll do everything for you behind the scenes. You don't really need to touch anything, but it still means different things, and as a customer who makes a decision or a user who makes a decision, you need to be aware of what you're selecting and what's the pros and cons for everyone. So if it was a very monolithic, simple application, HA might be very straightforward. But because we're talking about, and that's true for every large-scale application that has a composite, many component, and so on.
Thanks. So any other question from the audience? About, again, anyone else running OpenStack here? I'll start with that because I see that you're too shy today. Beyond Mesh, because I've seen few hands raised here. I need to actually force you to answer questions here. It's not an Israeli style of doing conferences. But anyway, the last question in that case, before we kind of end the panel, is there is the different tools that I think each one of you represents. And if I, again, wants to try out something right now, I know that Redhat has more than one tool. It has one for developers, one for production. I'm not sure if that's the case in Nebula. What would be the piece of advice that you would give me based on your experience?
I think
the
there's
do's and don'ts.
Yeah, I think there's a few things. If you're just setting up a really isolated lab, there's different scenarios you need to take into account. First of all, do you want to manage your infrastructure and your applications with similar tool sets? I think that's, it really depends whether you are the one managing the cloud and the VMs on it. Are you private, enterprise, and your customers are internally, then you probably, as an IT department, you need probably to take care for the VMs. Therefore, you might want to care for the infrastructure as OpenStack plus whatever is running on the VMs. If you're a public cloud, right, you don't care. The VMs needs to be there. If you're just a developer and you're not an operator, you just want to develop OpenStack, again, it's a completely different set of considerations. I think another realistic thing is that if you're an enterprise or you have an existing infrastructure, like VMware or maybe you already use EC2 or whatever, or just large investment in bare metal, you might want to consider using the same tools, same guides, same principles. Like a lot of organizations are familiar with Puppet and Chef, really like to keep on using Puppet and Chef. They don't want to have a specific solution for OpenStack and a specific solution for EC2, a specific, you really want to unify the tool sets that you're using. So in that case, Foreman could be a good candidate because it supports both Puppet and Chef. It works across bare metal and cloud and virtualization providers. And it does try to streamline the differences in a way that the operator, someone who actually consumes the system, makes it very straightforward for him to deploy. But again, it depends on the specific use cases. That's why I'm finding it hard to say this is the way you should be doing or going forward. You need to invest some time and understand what is your end goal.
Shevek?
I gave a presentation in Switzerland a couple of months ago, and the whole audience sat like this, and they were very polite, and they sat up and they listened, and nobody asked any questions at all. Please throw questions at us, because it makes it more fun for us as well as for you. And anyway, I didn't quite catch the question. Ask again, please.
So the question, what would be the single piece of advice if I would want to start now in OpenStack? What would be the single piece of advice that you'd give me?
If you wanted to start now with OpenStack and Nebula, you want a wireless network at home, you go around to Best Buy and you say, I want one, and you plug it in at home. And the same is true of Nebula. We have a warehouse full of the things. Get one, plug it in, plug some computers in at the back, and point your web browser at it, and you're up and running.
In that case, I want to point that question to you. What would be, why wouldn't I do that?
Why?
Why wouldn't I do that?
Why wouldn't you do that?
Yes. Because Omri said something about that. That he wouldn't pick that option.
I'm going to take this very seriously now. I have to. This is why they don't put me on panels, because I answer questions honestly. I have racks of computers in my house at home. And I will confess that I do not have a Nebula controller at the top of that rack. And yes, I do run VMs in them. But the flip side of that is it comes out in product roadmap. I spend more time managing VMs, even in my private racks at home. I've got 2 racks, which is small by any of your standards, I'm sure, and lots of machines. Yeah. Well, somebody asked me what I did with all of that, and I said, all those pictures of cats on the internet, they're here. Yeah, all of them. But the point goes on, I do not currently have a Nebula controller at the top of that rack. And this annoys me. And I spend time, and the reason I'm in the office of the CTO, I'm not business, I'm not sales, I'm not mainline dev. I'm out there trying to listen to people and invent things and solve problems. And one of the problems that I'm trying to solve here is my own. And at the rate we're going, I hope to have a Nebula controller at the top of my personal rack within, I guess, the next 6 months. And the things that we're doing in order to do that, one of the things that I think we're doing is we're reducing it to 1U high rather than 2U high. We're giving more switching options because I happen to use a different class of switch at home to the class that Nebula uses, but then I'm a slightly weird person from that perspective. Why wouldn't I do that? I personally will be doing it soon, but I'm not doing it right now for reasons which I am solving.
That's a very, very interesting answer.
I will go into more details if people want to. You've got a question. It's a hardware box, and it looks like a network switch. And when you plug computers into the back of it, those computers network boot off the switch, and the switch installs the OpenStack onto the target machine. So the process of building an OpenStack cloud is then put a Nebula box in the top of the rack, fill the rack with computers, plug them into the switch and turn them on, and they will just boot and become OpenStack. No, you have to buy the box.
It's an appliance model.
It's the same as buying a wireless router for your house. You buy a box and you plug it in. And it's meant to be that simple. One of the reasons that you have to buy the box is that then we know what the network setup is. We know what the chips are. We know what the hardware is. We know what the config is. We know absolutely everything about every piece of hardware in that controller. And it's actually got custom hardware in it for doing some of the security. One of the interesting things about running clouds is that if you fire up 20 or 30 VMs on a cloud, and each VM, when it fires up, it generates an SSH key. And each of those SSH key generators reads from the random number generator. And after the first 2 or 3, you run out of randomness. And so the next 30 boxes all generate the same key pair, and they can then all be cracked trivially by doing the large-scale GCD factoring thing, which some of you may have seen. So just as an example, one of the things which is in the Nebula controller is a hardware entropy generator which distributes across the cloud and solves the problem to guarantee that all of your VMs will generate different SSH keys. So that's why you buy a box.
Omri, a question to you. What would be the thing that you would recommend that I wouldn't? Like, what are the things that you've tried and you would recommend that I wouldn't go on that path?
Don't use Nova Network.
Don't use Nova Network, okay.
Yeah.
That's a good one.
It's terrible, actually, and it's not really like straightforward to migrate from Nova Network over to Neutron or Quantum, which it used to be. So, like, go ahead and start with Neutron. That's like the first thing that I would go with. And if I would recommend anything else, just do it. I mean, download OpenStack distribution. It doesn't actually matter.
What about monitoring toolchain? Is there a specific kind of toolchain that you would recommend would be the choice to minimize the number of choices that I have to deal with?
To monitor the system?
Yes, for example.
Well, I'm trying out Ceilometer right now as we speak. That's one of my installations that I'm doing right now. I haven't had the opportunity to try it out for like long enough to know if it's exactly what we need. I'm also integrating it with Ganglia just to get like metrics and everything. So that actually works out pretty nice for me. On monitoring, it depends what you want to monitor, I guess.
Mm-hmm. And the hardware that you choose, is there standard hardware or is that a specific one?
Today at Revizer, we're using a hosted solution over on SoftLayer, so
Okay.
I don't really have the ability to pick what I want. I just had like a couple of machines installed. That's more of our staging environment. For production, we're going to have our own data center somewhere with our hardware. That we'll probably like pick exactly what we need, tailored to our specifications, depending on what I'll find during our staging environment.
So you do use one of the recommended blueprints to pick the right hardware, or do you have your own kind of blueprints that you had in mind?
I think it depends on the configuration that I'll choose to go in eventually. For example, there are a couple of different ways to install OpenStack with Ceph. Do you install Ceph as part of your own part of the compute node, or do you do it separately? I mean, Piston Cloud used to do it on the same node. So you have like a Nova compute with Ceph on the same hardware. We're testing that out to see if that will work out for us, or if we'll just separate it. And based on that, we'll know if we'll need like different network cards.
And is there reasons for choosing Chef versus Puppet in your case, or is that?
Well, at LivePerson we chose Puppet for a different reason than why I'm using it today. Obviously, today I have more experience with Puppet, so that's easier for me to go with. So, in LivePerson we chose Puppet specifically since it was easier for developers to, like, who are not familiar with Ruby, to go in and start writing manifests for Puppet. So it was like really easy to just go in and dive in. It's really like the language for Puppet is really simple. So just
Alex, your last piece of advice. Keep it short because I think we're out of time already.
I would suggest something that probably most of the audience will be surprised or not be able to relate, but understand the financial model as to why you're trying to use OpenStack 4, because that will kind of lead you to what is it that you're trying to do in production and in development, because ultimately you do want to have the same environments, at least technology-wise, for the most part, be available in both, so that you can test against one and then promote to the other, and decide how you're going to scale it. Once you do that, you can decide whether you do a custom thing, if it's like a PayPal or a WebEx type solution, or if you want to take something out of the box and use interoperability options. And one of the things we're seeing is we see customers who, for example, decide to use CentOS as a cloud for development, and then go on Red Hat in production because it makes more sense. They're willing to pay for production, but for development they don't need to do that. And so those kind of hybrid solutions do coexist today. And then if you just want to be if you don't have an opinion of how you want to do things, then try to actually take somebody else's package solution, because these people have already figured out all the things, and you can do things very quickly these days. Whether you choose to do it through Appliance model, or take Red Hat OpenStack or Mirantis OpenStack or Piston. I mean, these solutions will now work out of the box, and pick your favorite one. I mean, we're getting to be fairly mature already, but understand the usage model first. That's the most important thing.
So if I summarize, we're running out of time right now, I'm sorry. Then I would say it depends, but use Foreman, use a box, don't use Nova Network, and it depends on the economical model. Right? That's a good summary? Okay, with that we'll end, and we'll take a coffee break right now. 10 minutes. Thank you. Thank you very much.